Hello students, welcome to this lecture on polynomials. In this lecture, we'll discuss NCERT exemplars on polynomials. Okay, so let's get started. This is our question number 1. So it said to us, if one of the zero of the quadratic polynomial k minus 1 times x square plus kx plus 1 is minus 3, then the value of k is what? Okay, so basically we have given a quadratic polynomial, that is actually here k minus 1 times x square plus kx plus 1. Okay, this is our given quadratic polynomial, sorry. And we have given one of the zeros of this quadratic polynomial is minus 3. Okay, so minus 3 is one of the zero of this quadratic polynomial. And we need to find the value of k. We need to find the value of k. Okay, so here we have given these 4 options. So among these 4 options, which option is actually in which option we have given the value of k? Okay, so let us solve this problem. So if we know alpha is the one of the zero of the quadratic polynomial f of x. F of x is equal to ax square plus bx plus c. Then f of alpha must be equal to 0. Okay, so f of alpha must be equal to 0. So given that one of the zero of the quadratic polynomial, say p of x is equal to k minus 1 times x square plus kx plus 1. Okay, so we have given this quadratic polynomial k minus 1 times x square plus kx plus 1. Okay, so then p of minus 3, this is equal to 0. Okay, p of minus 3, this is equal to 0. So now if we substitute the value of p, value of x equal to minus 3, okay, in this given quadratic polynomial, then we get k minus 1 times 3 square minus 3 square plus k times minus 3 plus 1, this is equal to 0. Okay, so we get this equation. We get this equation. So now if we simplify this equation, then we get 9 times k minus 1 minus 3k plus 1, this is equal to 0. Okay, and it implies 9k minus 9 minus 3k plus 1, this is equal to 0. And if we simplify this equation, then you get 6k minus 8k, this is equal to 0. Okay, and therefore the value of k is basically equal to 4 by 3. The value of k is equal to 4 by 3. Okay, so the value of k is equal to 4 by 3. So here you can now verify in which option we have given 4 by 3. So here you can see in option number A we have given 4 by 3. Okay, so the value of k is equal to 4 by 3, and here the correct answer is option number A. Okay, now let us move to question number 2. So in this example we have given a quadratic polynomial whose zeros are minus 3 and 4. Okay, so here we give this informations. The zeros of this quadratic polynomial are minus 3 and 4. Okay, so now we have to find that quadratic polynomial. Okay, so let's solve this problem. So here we first let ax square plus bx plus c be a required polynomial whose zeros are -3 and 4. Okay, so here basically we first let this be a required polynomial whose zeros are -3 and 4. Okay, then the sum of zeros, that is equal to -3 plus 4, this is equal to 1. Okay, so this is actually equal to 1. Okay, sum of zeros equal to 1, and we know sum of zeros of a quadratic polynomial ax square plus bx plus c is basically minus of coefficient of x divided by coefficient of x square. Okay, and here the coefficient of x for this quadratic polynomial is b. Okay, and the coefficient of x square is a. So minus b upon a, this is equal to 1 by 1, and we can write this is as minus b upon a, this is equal to minus of -1 by 1. So sum of zeros, so therefore sum of zeros is minus b upon a, and now product of zeros, that is equal to actually alpha into beta, that is -3 into here -3 into 4. Okay, and this is equal to -12. So therefore product of its zeros equal to -12. And now we can write product of its zeros as t upon a, this is equal to -12 by 1. Okay, and now from this equation, naming this equation 1. Okay, and this equation number 2. Okay, so from these two equations, from equation 1 and 2, here if we take a is equal to 1, then b is equal to a is equal to 1, then b is equal to -1, and c is equal to -12. Okay, so therefore the quadratic polynomial ax square plus bx plus c, so therefore the required polynomial is equal to 1 times x square minus 1 times x minus 12. Okay, so this is the required quadratic polynomial. So this is, if we calculate it, then this is equal to x square minus x minus 12. Okay, and we can also write it as x square by 2 minus x by 2 minus 6. Okay, so we know that if we multiply or divide any polynomials, be any constant, then the zeros of the polynomial do not change. Okay, do not change. So we can also solve this problem by alternate method. Okay, alternate method, what is that alternate method? So you can let the zeros of a quadratic polynomial are alpha is equal to -3 and beta is equal to 4. Okay, and the sum of zeros, that is equal to alpha plus beta, and this is equal to 1. Okay, and the product of zeros, this is alpha into beta. Okay, and this is equal to -3 into 4, that is equal to -12. So product of zeros is equal to -12, and therefore the required polynomial is equal to x square minus sum of zeros times x plus product of zeros. Okay, that is equal to x square minus 1 times x plus -12. Okay, and if you simplify this, then you get this is equal to x square minus x minus 12. Okay, so now you can divide this polynomial by 2, since if we multiply or divide by a constant of a polynomial, then the zeros of that polynomial does not change. Okay, so we can write this polynomial as x square by 2 minus x by 2 minus 6. Okay, so this is our answer. So now let us move to question number 3. So in question number 3, here it's said to us, if the zeros of the quadratic polynomial x square plus a plus 1x plus b are 2 and -3, then we need to find the value of a and b. Okay, so student, here let us solve this problem. So here first let p of x, here we first let p of x. So here we let p of x x, this is equal to x square plus a plus 1x plus b. Okay, and given that 2 and minus 3 are the zeros of the quadratic polynomial p of x. Okay, so 2 and minus 3 are the zeros of the quadratic polynomial p of x. So therefore p of 2, this is equal to 0, this is equal to 0, and p of minus 3, this is equal to 0. Okay, and if we substitute the value of x equal to 2 in p of x, then we get this equation. Okay, then we get this equation 2 square plus a plus 1 times 2 plus b, this is equal to 0. Okay, and it implies 4 plus 2a plus 2 plus b is equal to 0, and it implies 2a plus b, this is equal to minus 6. Okay, and naming this equation number 2. And if we substitute the value of x equal to minus 3 in the polynomial p of x, then we get this equation minus 3 square plus a plus 1 times minus 3 plus b, this is equal to 0. Okay, and if we simplify this, then we get this equation 9 minus 3a minus 3 plus b, this is equal to 0. Okay, and it implies 3a minus b, this is equal to 0. Okay, so 3a minus b, this is equal to 0. So okay, so this is, so we get this two equation, 2a plus b is equal to minus 6 and 3a minus b is equal to 6. Okay, so here we naming this equation as 1 and this equation as 2. Okay, so one adding equation 1 and 2, we get 5a, this is equal to 0, and it implies a is equal to 0. Okay, and put the value of a in equation number 1, we get 2 times 0 plus b, this is equal to plus 6, this is equal to minus 6. Okay, and it implies b is equal to minus 6. So the value of b is equal to minus 6. Okay, so the required value of a and b are 0 and minus 6 respectively. Okay, so the value of a is equal to 0 and the value of b is equal to minus 6. So a is equal to 0 and b is equal to minus 6. Now let us move to question number 4. So here we have asked the number of polynomials having zeros as minus 2 and 5. Okay, so here we have given in option A 1, in option 2 we have given 2, in option C we have given 3, and in option D we have given more than 3. Okay, so let us solve this problem. So here first we first let p of x, this is equal to ax square plus bx plus c. Okay, and we let this be the required polynomial whose zeros are minus 2 and 5. Okay, and sum of zeros, this is basically equal to minus of coefficient of x divided by coefficient of x square. Okay, so sum of zeros is equal to minus b upon a, and here minus b upon a, this is equal to sum of zeros, and here we are given the zeros of this quadratic polynomial are minus 2 and 5. Okay, sum of zeros is equal to minus 2 plus 5, that is equal to 3, and you can write 3 by this is 3 by 1, and this is equal to minus of minus 3 by 1. Okay, and now the product of zeros equal to c upon a, and c upon a, this is actually product of zeros, and we have given the zeros are minus 2 and 5. So c upon a, this is equal to minus 2 times 5, and this is equal to minus 10, and you can write minus 10 as minus 10 over 1. Okay, so you can write this. So now naming this equation 1, and naming this equation number 2. Okay, so now from equation number 1 and equation number 2, a is equal to 1, b B is equal to minus 3, and C is equal to minus 10. Okay, so therefore the quadratic polynomial P of X whose zeros are minus 2 and 5. Okay, so that is P of X is equal to ax square plus bx plus c, that is equal to 1 times x square minus 3x minus 10. Okay, and this is equal to x square minus 3x minus 10. So here we get one quadratic polynomial x square minus 3x minus 10 whose zeros are minus 2 and 5. Okay, but we know that if we multiply or divide any polynomial, be any arbitrary constant, okay, any polynomial be by any arbitrary constant, then the zeros of the polynomial never change. Okay, the zeros of the polynomial never change. So therefore P of X is equal to k times x square minus 3kx minus 10k, where k is a real number. Okay, so this is and we can write P of X, this is equal to x square minus x square by k minus 3 by kx minus 10 by k. Okay, so here k is arbitrary, hence the required number of polynomial are infinite. Okay, so the required number of polynomials are infinite, that is more than 3. So here option number D is correct answer. Okay, so for this question option number D is correct answer. Now let us move to question number 5. So in this question we have asked if one of the zeros of the cubic polynomial ax cube plus bx square plus cx plus d is 0, then the product of then other two zeros is what? Okay, so we have given 4 options. In options A we have given minus c upon a, in option B we have given c upon a, and in option C we have given 0, and in option D we have given minus b upon a. Okay, so let us solve this problem. First let us try yourself and see the answer. Okay, so here thinking process, what is that? So firstly we find the sum of product of two zeros at a time. Okay, and put the value of one of the zeros is 0. Okay, so that is 0. We get the required product of the other two zeros. So here first we let P of X, this is equal to ax cube plus bx square plus cx plus d. Okay, so this is given to us. Okay, if we have given this cubic polynomial, and given that one of the zero of this cubic polynomial P of X is 0. Okay, so one of the zero of this cubic polynomial is 0. So let alpha, beta and gamma are the zeros of the cubic polynomial P of X, where a is equal to 0. Okay, and we know that sum of products of two zeros at a time, that is actually equal to constant coefficient of x divided by coefficient of x cube. Okay, so alpha beta plus beta gamma plus gamma alpha, this is equal to c upon a. And here we have given 1 0 of this cubic polynomial is 0. Okay, so suppose here we let alpha is equal to 0. Okay, so then 0 times beta plus beta times gamma plus gamma times 0, this is equal to c upon a. Okay, so now it implies beta times gamma, this is equal to c upon a. So the product of other two zeros is equal to c upon a. Okay, so the product of other two zeros equal to c upon a. Hence the product of other zeros equal to c upon a. So let us move to question number 6. So in this question it said to us if one of the zeros of the cubic polynomial x cube plus ax square plus bx plus c is minus 1. Okay, so one of the zero of this cubic polynomial is minus 1, then the product of other two zeros is what? Okay, so here we have to find product of other two zero. So let us solve this problem. So firstly, we find the value of constant term c. Okay, so we find first the constant term c by using p of minus 1. This is equal to 0. Since minus 1 is one of the 0 of this cubic polynomial. Okay, so p of minus 1, this is equal to 0. And after that, we find the product of all zeros and put the values of 1 0. One of the zeros is minus 1. And finally, we get the required result. Okay, so here we let p of x, this is equal to x cube plus ax square plus bx plus c. And let alpha, beta and gamma be the zeros of the given cubic polynomial p of x. Okay, so alpha is minus 1 and p of minus 1, this is equal to 0. Okay, so now if we substitute the value of x is equal to minus 1 in the given cubic polynomial, then we get minus 1 cube plus a times minus 1 whole square plus b times minus 1 plus c is equal to 0. Okay, and if we simplify this equation, then we get c is equal to 1 minus a plus b. And we know product of all zeros, that is equal to minus 1 minus of constant term divided by coefficient of x cube. Okay, and here the constant term is c, so this is equal to minus of c over 1, since the coefficient of x cube is 1. Okay, so now alpha, beta, gamma, this is equal to minus c, and we have given 1 0 is minus 1. Okay, so here we let alpha is minus 1, then minus 1 times beta gamma, this is equal to minus c, and it implies beta gamma, this is equal to c, and it implies beta gamma, this is equal to 1 minus a plus b, since we already find the value of c is equal to 1 minus a plus b. Okay, hence the product of other two roots is 1 minus a plus b. Okay, so here for this question, option number 1 minus a plus b. Okay, so here option number a is correct answer. Okay, so option number a is here correct answer. Now let us move to question number 7. So the zeros of the quadratic polynomial x square plus 99x plus 127 are both positive, both negative, one positive and one negative, and both equal. Okay, so we have given these quadratic equations and we have to check the zeros of this quadratic polynomial. Okay, so let us solve this problem. So here we let the given quadratic polynomial p of x be p of x is equal to x square plus 99x plus 127, and when comparing p of x with ax square plus bx plus c, we get the value of a is equal to 1, b is equal to minus 9, b is equal to 99, and c is equal to 127. Okay, and we know that x is equal to minus b plus minus root over b square minus 4ac divided by 2a. Okay, and if we substitute the values of a, b and c in this formula, then we'll get the value of x are minus 1.3 and minus 97.7. Okay, so here we get these values by quadratic formula, and hence both zeros of the given quadratic polynomial are negative. Okay, and here we can also do by alternative method. So we know that in a quadratic equation, if the quadratic polynomial, if coefficient of x is positive and coefficient of x is positive and the coefficient constant term is positive, then both zeros are negative, or a less than 0, b less than 0, c less than, then also the zeros are negative, both are negative. Okay, so in the given polynomial we see that a is equal to 1, that is positive, b is equal to 99, this is positive, and the value of c is equal to 127, this is also positive, so which satisfy the above condition. Okay, so the both zeros of the given quadratic polynomial are negative. Okay, so the both the zeros of the given quadratic polynomial are negative. So here option B is correct answer. Okay, so I stop here this lecture. Thank you very much to all of you.